Let's look at 5.3. So in chapter 5, we're all talking about polynomials. And in 5.1, we talked about adding and subtracting. In 5.2, we introduced the idea of multiplying polynomials. But in 5.3, we're getting into a little bit of the nitty-gritty, talking about some of the special cases and stuff like that. So as we get in, you may or may not be familiar with the idea of the FOIL method. FOIL method is just first times first, outer times outer, inner times inner, last times last. And it really works for binomial times binomial. However, it's just a distributed property. So, and we'll walk through it in just a second. But the idea of FOIL starts to fall apart once you get out of the binomial times binomial situation. If it's any other kind of multiplication, it doesn't really fit. But it is just distribution, so distribution works regardless. Okay, so let's take a look at number 1 here. So I'm going to take my first term here, and I'm going to move it, or multiply by everything in the second parentheses. So, and that's where the first times first and the outer times outer comes from. So x times x is first times first, that's going to be x squared. X times 2 is outer times outer, and that's 2x. All right, then you take the second one, 4, that's inner times inner. And then 4 times 2, that's going to be last times last. Watch your signs. So it's going to be negative 4x. It's going to be negative 8. And then you just want to make sure you combine like terms and clean everything up before you're done. All right, so that's going to be x squared. I got 2x minus 4x. That's going to be negative 2x minus 8. And there's your answer. Okay. Now, on number 2, same process. I'm going to take the 2x and give it to everything on the other side. So it's going to be 2x squared. That's going to be 6x, so plus 6x, negative 3x, and negative 18. So negative 3x, negative 18. Again, you're just going to clean it up. So you got 2x squared plus 6x. Oops, forgot to clean it up. 6x minus 3x is 3x. I got 3x minus 18. Okay, so there's that. Now, you'll notice on 1 and 2 that x was first in the parentheses, in the binomials. And then my answer was x squared, and then x, and then a constant term. So when you get to number 3, and then the x is in the back of the binomial, you're going to see that that's just going to change the order. On 1 and 2, because it starts high and then trickles down, that's what we call descending order. And 3 is going to result in an ascending order answer. So let's get there. So 2 times 4 is 8. 2 times negative 5 is negative 10x. 5x times 4 is 20x. And then 5x times negative 5x is negative 25x squared. Clean it up. It's going to be 8. Negative 10 plus 20 is plus 10, so plus 10x. And then minus 25x squared. All right, so you'll notice, again, on 1 and 2, all right, you had x squared, x, and then a constant term, x squared, x, and then a constant term. And then on 3, it was constant term x squared. And on number 3, that is what we call ascending order, because with each term, you get a higher exponent. Typically, these are written in descending order, and I could have rewritten that to be in descending order, but it's not necessary. Now, on number 4, this is one of our special ones. So let's get into it. So if you notice, if you just look at it, they're the exact same binomial except for the signs. One's positive, one's negative. Same thing on number 5. One's positive, one's negative. Now, pay close attention to how this plays out. So I'm going to do the whole process like I've been doing. So it's going to be x times x, which is x squared. X times positive 6, which is 6x. And then inner times inner is negative 6x. And then last times last is negative 36. Well, what do you notice? You notice that I get a positive 6x and a minus 6x in the middle. So those are going to fall out. And I'm just going to be left with x squared minus 36. So as I said, this is a special case. And this is what we call the difference of two squares. This whole relationship we got going on here. This is a difference of two squares. And when we get to chapter 6, we'll really get into it, because that's when we start talking about factoring, which is the reverse of what we're doing right now. Right now we're multiplying. Factoring goes in the other direction. Okay, so there's that. So I just wanted to, I'm not really going to get into the difference of two squares. I just wanted to point it out to you so that when you see it again in chapter 6, you'll remember it. Okay, so here, it doesn't really matter that this is a cubed and not a square, because when you multiply like bases, you add the exponents. So when I multiply, this is going to be y to the 6, because 3 plus 3 is 6. Okay, and then it's going to be negative y to the third, negative 4y to the third, plus 4y to the third, and then that's going to be minus 16. And then once again, you'll notice that the middle term falls out. Okay, okay, so that's going to be y to the 6 minus 16. Okay, so that's my answer. Now, 6 is another special case. All right, and I want to draw your attention to it because most students, I don't know if they're in a hurry or what, they screw this one up a lot of times, and it's kind of like an unforced error. What do I mean by that? Well, for starters, x plus 2 all squared means I have 2 of these. So it might benefit you to go ahead and rewrite it, because now it looks like what we've been doing. Because what students tend to do is they say x squared is x squared, 2 squared is 4, and then they write x squared plus 4, and that's completely wrong. There is a middle term in there that often gets left out, and if you leave it out, it is wrong. All right, so it's going to be x squared plus 2x plus 2x plus 4. Okay, so if you clean that up, this time the middle term doesn't fall out, but it does clean up. So we got x squared plus 4x plus 4. So there is a middle term, and if you leave it out because you forget that this is, when it says a parentheses squared, it actually means you can write it twice, and therefore you can multiply it out and stuff like that. So if you don't write it out, it will be wrong. Okay, and I said this one's special because it follows a pattern. This one, 6 and 7 both follow a pattern. Okay, and that pattern is this. If you have a plus b all squared, it's going to follow the pattern of a squared plus 2ab plus b squared, which means you're going to square your first term, square your last term. That part's true, but you have that middle term, and you take your two factors inside the binomial, multiply them together, and double it. All right, so just watch out for the sign. And then 7 is the other version of that, where you have a minus b all squared. And all that changes is your sign, the first sign. Because you're squaring that last term, right, your last term is always going to be positive. So this is going to be a squared minus 2ab plus b squared. Okay, so let's kind of talk through it for a second. So we expect this to be my first term squared, so that's going to be x squared. My second term squared is going to be my last term, so that's going to be a positive 9. And then if I take the two terms together, x and 3, or x and negative 3, I multiply those two together, I get negative 3x, and then I double it, it's negative 6x. So I should get x squared minus 6x plus 9. All right, so let's play that out. So I got x minus 3 times x minus 3, because remember I have to write it twice. All right, that's going to be x squared minus 3x plus 9. Okay, x squared minus 6x plus 9. Well, there you go. It follows the pattern. I squared my first term, squared my last term, and then I take my two terms and multiply them together, double it, and I get my middle term. Okay? All right. Now, again, we're on number 8 now, and that FOIL doesn't really work here. But remember, FOIL is just a type of distribution. All right, so we're just still going to distribute. We're just going to take this x, and we're going to give it to everything. So x times x squared is going to be x cubed, and it's going to be minus 5x squared. That's going to be plus 25x. Then I move to the next one. I got 5 times x squared, so plus 5x squared. That's going to be minus 25x. And then that's going to be positive 125. All right, clean it up. You have a negative 5x squared and a positive 5x squared, so those are going to fall out. You got 25x and a minus 25x, so those are going to fall out. And this would be x cubed minus, or excuse me, plus 125. We'll talk about this type of problem again in chapter 6. So stay tuned for that. Okay, number 9. It's just like 6 and 7. All right, you got x squared plus 6 times x squared plus 6. Okay, so x squared plus 6. All right, so that's going to be x to the 4th plus 6x squared plus 6x squared plus 36. Clean it up. You have x to the 4th plus 12x squared plus 36. Okay, there you go. Now, number 10 is what we might call an application problem. It's the same thing that we've been doing, same concept, but now it's applied differently. When you are looking for the area of a rectangle, that's base times height. Okay, so you're literally just multiplying your two sides together. So when you do that, you get 2x minus 9 2x plus 9. And then you do the same thing. So it's just asking you to look at this a little differently, but you're still doing the same math. Okay, so here, you get 2x and 2x. 2 times 2 is 4. X times x is x squared. All right, 2 and 9 is 18, so I got plus 18x, minus 18x, and then minus 81. All right, my middle term is going to fall out. Okay, that's going to be 4x squared minus 81. And I'm going to write this one in parentheses just because when you're dealing with something like this, you have units to contend with. And so right now I have feet and feet. And so when I multiply feet times feet, I get feet squared. And so when I put my units on here, it applies to the whole thing. So I'm just trying to be clear by wrapping it in parentheses. So that's going to be feet squared. All right, last problem. Now, before we get into this, I really just want you to put, I got my first term, my second term, my first term, my second term, and the only thing that's different is the sign in between. So this is also a difference of two squares situation that we saw back on number 4 and 5. But, all right, it's just a little more complicated, but it doesn't change how you work it at all. So you just do it one thing at a time. All right, so x times x is x squared. X times 5 is 5x. X times y is y. You could say yx or you could say xy. I typically prefer to write them, and you typically see them in alphabetical order. But all you need, if you write it yx, you just need to know that xy and yx is the same. So they're still like terms regardless of the order. That's the only thing that matters there. All right, so we've finished with this first x. Now let's move on to the 5. Okay, so I have 5 times x, that's going to be 5x here. 5 times 5 is 25. 5 times y, it's going to be 5y. Okay, and then I move to the next part. Negative, that's going to be minus xy. That's going to be minus 5y. And that's going to be minus y squared. Okay. All right, so I have x squared. You have 5x and 5x. So that's going to be 10x. All right, you have a plus xy and a minus xy, so those can fall out. You have 25, so plus 25. You have a minus and a plus 5y, and then a minus y squared. All right, so sometimes there is no order to this thing. So this is what we're looking at. This is my answer. All right, and as long as all of your, just as long as all your terms are there and the signs match up, that's all you really need to concern yourself with. All right, guys, that is 5.3. I hope you enjoyed it, and good luck on the homework.